What's going on, y'all? Let's go ahead and solve some rationals in this video. So I have just a couple examples, but I'm going to be doing this first one in two different ways. So it's basically three examples. Alright, so this you have fraction equals fraction, and you can do this in two different ways. And you can only do this first way if it's fraction equals fraction. And this first way is known as cross multiplication or the butterfly method. So, of course, whenever you circle the pairs that you're going to multiply, it does kind of look like a butterfly somewhat. So when you cross multiply, you should get x times x plus 5 is equal to 2x times x plus 1. So now if you just distribute, you get x squared plus 5x and 2x squared plus 2x. And just solve for x normally, you should get x squared minus 3x. So to solve, you do have to factor the GCF, which is x. And you should get x is equal to 0 or 3. So just to bring up kind of an edge case, if x were to equal, if you solved all this stuff and x at the end was equal to -1 or -5, that would actually be an extraneous solution because -1 and -5 are not part of our domain since they are in the denominators. So that's one thing to look out for. Okay, so now the other way I'm going to do this is, let's go ahead and rewrite the question up here. The other way I'm going to do this is by multiplying both sides by the least common denominator. So what I'm going to do is I am going to draw some parentheses, and we're going to multiply both sides of the equation by the least common denominator. So do we have an x plus 1 term? We do not yet, so I'm going to multiply both sides by that. And let's kind of move on to the next fraction. Do we have an x plus 5 term already? We do not, so I'm going to multiply this by that. So this is going to be our least common denominator. So now let's go ahead and multiply both by that. If we multiply this first fraction by that, the x plus 1s will cancel out, and you'll end up with x times x plus 5. And the second one, well, when we multiply that by the least common denominator, the x plus 5s will cancel out, so we're going to be left with 2x times x plus 1. And as you can see, the result is the same as the butterfly method. Like these two are the exact same thing, so you can just follow the work down this way. But the way that we got there is a bit different. And you might be like, well, why would we ever use this and not the butterfly, or not cross multiplication, because cross multiplication is easier? Well, in the next example, it actually might be easier to do the least common denominator. So as you can see, this one's a bit different because on the left side, we have an addition. It's not just fraction equals fraction. So we can't do the butterfly method. Now what you could do if you really wanted to do the butterfly method is you could just add the two terms on the left by getting a least common denominator, adding them, and then doing the butterfly after that. You could do that. Or alternatively, you could multiply both sides by the least common denominator. And let's kind of find out what happens. But the first thing I'm going to do actually is go ahead and factor everything first. So let's go ahead and factor this thing. This is going to be x times x plus 2. So I'm just going to go ahead and sketchily rewrite this like this. Alright, so we could cancel out these x's. So let's go ahead and do that. Why not? We can simplify a bit. Alright, so now we have to multiply both sides by the least common denominator. So I'm going to write this parentheses. And let's go from left to right. Do we have an x plus 2 term in our least common denominator yet? We do not, so we're going to add that to this. Do we have an x term in our least common denominator? We do not yet, so let's go ahead and add that to what we're going to multiply. And then, do we have an x plus 2 term? We already do, so we don't need to add that to our least common denominator. So now we have to multiply every single term by this. And for the first one, well, the x plus 2's will cancel out. So we're just going to be left with x times x minus 1, which is the numerator. That's how I got that. And then plus 1 over x times this. So the x's will cancel out. So you're just left with x plus 2, or 1 times x plus 2, is equal to 3 times the x plus 2's will cancel out, so you're just going to be left with 3x. And now we can solve this like normal. So let's go ahead and distribute this. X squared minus x plus 2 equals 3x. So these will cancel out, and you get x squared minus 3x plus 2 equals 0. So of course we can factor this as such, and we get x is equal to 2 or 1. And again, if these values were to equal -2 or 0, those would actually be extraneous solutions, because those would be excluded values. They would not be part of our domain, since they are corresponding with the terms at the bottom. So that's going to be it for this video. I know it's kind of longer just for 2 examples, but it'd be like that sometimes. So I'll see you in the next one.